Thank you. So, Roland Hedberg. I hope you don't have a problem with my accent. As you can hear, I'm not sort of a US citizen, I'm from Sweden. So if you have any problem with that, sort of just ask me to repeat what I'm saying. I have a lot of slides, but even so, if there is questions, please ask them, and we'll try to get them sort of when they come up. So, to understand OpenID Connect, you have to understand the clicker. Good. Okay, so take next one. So, OAuth2, it's about authorization. And some of you may have been sort of here at the track before lunch, so you heard all about this. It's about authentication, about sort of resource owner giving access to his or her resources and sort of to services and such. And these are the players. You have the resource owner. Oh, good. Which we may call Alice. But anyway, so you have a client, you have an authorization server, and you have a resource server. A resource server, of course, is the one that is actually providing the resources. The authorization server, in this case, consists of two computers, you could say here. But that's because it actually provides two different endpoints for doing things. And that's why I represented it as two. So to start off, you have the authorization request. And it, of course, goes to the authorization endpoint. And this is what you can do in that request. There are a number of parameters you can use. You have to identify yourself as a client, so you provide the client ID. You have something called the redirect URI, which is where the authorization server will send you back to when you have done the authentication. You have a response type, which describes how the process is going to happen when you do this. There are, as if you were here before lunch, there are 4 different flows. So this is where you pick which flow to use. There is scope, which is also sort of talked about earlier. It's what you want to do with the resource. And then it's state, which is, since you get back this, it's not a synchronous event. This is asynchronous event. So in order to be able to map this request, this answer you get back from the authorization server to what you have been doing, you have to have some kind of key, and that's the state. And at the bottom there, you can see sort of an example of what one of these requests will look like. It's supposed to be a URL encoded, but I removed that, so it's actually a bit more readable. Then, when you've done that, you have the authentication, and you have the consent and authorization stuff. And that's not part of the standard. It happens outside the standard. And again, this was discussed before lunch. This allows sort of the authorization server to use different types of authentication in different contexts. And then the authorization server constructs the response and sends it back. And part of that is then the code, which is the access code. That's the sort of then supposed to be used later on for getting the access token. I placed the parameters here in 2 groups. And that's because the group on the right-hand side, left-hand side, sorry, from your point of view, is when you're using the code flow. And the one on the the right-hand side, is when you're using the implicit flow, the token flow. But we're dealing with the code flow here. So you get back code, and you get back the state value that you specified in the request. So you can map this into what you have been doing beforehand. Then you take this code, and you send it to the authorization server again, but you send it to the token endpoint. So not the authorization endpoint anymore, but the token endpoint. And what you send is the client ID again, the code that you got from the authorization endpoint, the Gran type, and the redirect URI. And the redirect URI is the same, supposed to be the same as you had when you sent the authorization request. And in this case, it's a post, it's not a get. And then you get back the response. And the response is the access token, of course, which is what you wanted. The information about that, like when it expires, and the token type. But also the before mentioned refresh token, so you can get a new access token. And there are different lifetimes of these. So an access token is normally very short, and the refresh token is much longer. And the scope you get back here may not be the same scope that you asked for when you sent in the authorization request. The server is completely free to actually change that. You may have said that I want to have these type of accesses, sort of, and the authorization server responds with giving you some other, which might be a subset of what you asked for. But that's up to the authorization server. And the response in this case is a JSON document. No XML, so it's actually readable, and it actually fits on the page also. And then you have the resource access. You use the key, the access token you got, you send it to the resource server, and you get back whatever sort of the scope and define that you are supposed to get back. And normally, the most normal case, I think, is you send it as a bearer token. So you send it in the HTTP header. That's where you put the token you got back, the access token you got back. So that's it. That's the whole of OAuth. And this is the code flow. As you said, there are different types of flows. So you have the authorization code, the code flow, and then you implicit, the resource owner, and client credentials. Implicit is actually sort of you're skipping part of the steps. You're not doing authorization first and getting a code and then going to the token endpoint and asking for the access token. You want to get the access token directly, so there is no in between getting a code. So it's much simpler, but they also have some security problems. Because now the browser actually can see the access token. Resource owner and client credentials, then you have sort of skipped the user. The resource owner isn't there anymore. And you also skipped sort of the authentication request, authorization request. It's also not there. You go directly for the token request. And when you do the token request, you authenticate by either using username and password, which then the program in the services in some way got from the user, or the service as such has its own credentials, which it may then use. And that's the one at the bottom. So that's all you need to know about OAuth. It's simple. It's very straightforward. And you can build a lot of complex things on top of that. So now we go into OpenID Connect, and there are some people who are responsible for this. And I'd like actually to shout out sort of their names. John, for instance, one of them, and I'm sure he will. He's the irresponsible person of this troika, yeah. Mike Jones, Nat Sakimura, and John then. It was actually quite funny when I tried to look for this pictures and searching for Nat, you got him directly. Mike Jones, I think I got some rapper or something like that, musicians. And I looked for you, John, I got some guy who was playing in some film or something like that. So that's you, just your alias, right? So it's referred to as a simple identity layer on top of the OAuth protocol. I'm saying OAuth all the time. That's because OAuth2 is sort of very tough to say all the time. So I'm simplifying. And it enables clients then to verify the user. So not just how the authentication happened, but also sort of information about the user. So how does it do that? Well, there are a couple of differences. It cuts down on the flows. So for security reasons, among other, it's only doing code and implicit flow. Well, actually, it's doing another one too. It's something called a hybrid. We'll look at that. It added dynamic provider discovery, dynamic client registration. OAuth doesn't sort of tell you how you get the client ID, the client secret. It's just supposed to happen in some way. And in most cases today, you go to a website and you register by manually, sort of out of band way. And of course, there are reasons for that. I mean, the service providers usually want to keep track on who is using their service. Just letting it sort of float and let everyone sort of register dynamic clients might not be optimal, because you don't know who is behind. A lot of things thought about that presently because you really like to have it dynamically. But I don't know if there's any sort of really, really good solution for that. Also, there's added the ID token, which contains information about the authentication event. There are a number of additions, clarifications, constrictions. And then it's the user info endpoint, where you can get information about the user. I go through these now, one by one. So to start with the flows, we have the authorization code, we have the implicit flow, as OAuth has. I added two more, which is, added three more, which are the hybrid versions. So, and it's authorization code with a twist. So you do the authorization code, but you can also get back not just the access code, but you get back the ID token immediately, for instance. And that's an optimization, because that's really what you want sort of. And every call you make is actually, it costs you time. So you want to optimize that. You just want to make one call and get all the necessary information. Code token, then you get sort of both the code and the access token as a reply from the authorization request. And the third one of the hybrid is then the code ID token. So you get both the code, you get the token, and you get the ID token. You get everything immediately, sort of. Interesting thing there is, of course, that if you then use the token at the token endpoint, do you get the same access? Well, if you use the code, rather, at the token endpoint, do you get the same access token that you got the first time? Not necessarily. Not necessarily. Exactly. So dynamic provider discovery. I had this is actually two woodpeckers. There is no mirror, sort of, one looking at it. There is two. I had them sitting in a tree outside the window. pretty neat. So dynamic discovery and registration. First, of course, so the story is that you as a user, as a person, you come to this service and you want to authenticate. Now, how do you tell the service where to go and do the authentication? You have to provide the service with some kind of information. In the SAML case, for those of you, I'm heavily involved in SAML federations, so I do a lot of work with that. But in that case, you have something called where are you from, or you have a discovery service. So what happened in there is you get a list of all the identity providers, and then you have to choose the one you want to use. And this list can be tremendously long, like thousands of entries, which is a bit problematic when you want to do a very nice user interface to that. How do you do that? We'll struggle with that in Sweden, because if you want to do a search, for instance, and some of the names of the IDPs are in Swedish, some of them are in English, and some of them may be in other languages, and how do you do sort of a search algorithm that actually works over those different languages? In the OpenID Connect case, there is no, well, in SAML, what you base this where are you from list on is a metadata file, a file that contains information about all the IDPs that the service knows about. There isn't any such file in OpenID Connect. There is no metadata file which contains all the IDPs, or rather OPs, which is the correct name in OpenID Connect terminology. So you have to do it in a different way. So what you do then is that you have some kind of user identifier. And like you have a carol@example.org. It looks like an email address. And it may be an email address, but not necessarily. It's some user at some domain. And from that, you construct this HTTP GET. Basically, what you do is you take the domain part, let's call it an email address so far, but the main part of the email address, and you send the request to that website. And you add the path .wellknown/Webfinger. And then you add some information, some query parameters. The resource in this case it's called ACCT, which is account information. It could also be the email or a third schema that's supported is the URL schema, HTTP that is. And then in this rel parameter, you specified what kind of pointer you want back to, what kind of relationship between this person and the service you're after. In this case, you want to have the OpenID Connect issuer. There is some fly or something flying around there. Going back and forth. So when you send that, you get back a response which looks like this. There is a subject, which is what you started off with, carol@example.com, and then you get the number of links. And in this case, it says that the OpenID Connect issuer is this, you can find that at this reference. This is the sort of, you get the response the first time. There's a possibility also that you get a link where you can go and ask again. So you can have some kind of referrals. Now, if you take that HTTP openid.example.com and go there, add another path, which is .wellknown/OpenID configuration, you will get the provider information. And I'm not listing all the parameters here because there are a number of them. But basically, you will get one parameter that says this is the name of the issuer, which is the same. Actually, it's supposed to be the same URL as where you put the question. You will get EVK's URI, which is a pointer to a web page where you can get key material for this server. This is the public part of an RSA key, for instance. This is the public part of elliptic curve key or something like that. You also get information about endpoints. Where is the authorization endpoint? Where is the token endpoint? Where is the registration endpoint, which is where you want to go if you want to register the client, and so forth. Where is the user info endpoint? There's a set of functions which you also want to understand if they are supported or not. There's support for signing, encrypting algorithm. Which algorithms can you use? Can you use RSA 256 and so forth? And there are also information about policy and terms of service that you can get back from the provider. These are the required parameters that you are always supposed to get back. Again, the issuer, the EVK's URI, where's the authorization endpoint? Token endpoint only, of course, if you support it. I mean, if you only do implicit, no one is going to go to your token endpoint. Or token endpoint only used if you use code flow. Response types supported, that is again sort of if you're supporting code, token, code, ID token, code, token, ID token, and so forth. Subject type supported. This is about the identifier for the subject you get back. There are two versions of that. Either you get back an identifier which is specific to the subject, but it's the same, disregarding which service is asking for this information. That's called public. The other one is pairwise, which then is this identifier you get back is specific for this pairwise combination of OpenID, connect provider, and the relying party. The client is asking. So you get a new one for each of these, each such pair. And lastly, you get the signing algorithms for the ID token. And that's, there is mandatory to implement algorithm, and that's RS-256. But you can also use none, which means that it's not going to be assigned. And then you can have a number of other algorithms, of course. Now you want to do the sort of the client registration. This is actually quite interesting. Part of that is, so this is what the client sends. It sends descriptions of the URIs. This is the redirect URIs it's going to use. It can use more than one. It's application information like the contact for this service, email address, name or something, telephone number or something like that, to the contact for this. Support then for signing encrypting algorithms is the same as for the provider. Key material, again, is the same as for the provider. It's a EVK's URI. But you can also, in this case, the client can send the key material in the client registration request. So it can choose either to give a URL or they can send the information. The benefit for sort of using a URL is that then you can change the content at that URL at any point in time. You can do key rollover, which is very hard if you send sort of the information once. It's not able to update it. And then there are information about sort of what kind of behavior do I want from the server, and again, sort of what kind of client behavior do I want. And the only required information is the redirect URIs. All the other stuff is optional. But now comes the interesting stuff. The response from the server then contains client ID and possibly also a client secret, and if so, when it expires. And the authorization server's view on things, the provider's view on things, because the authorization server may change everything that the client said. So the client says, I want to sort of use these keys, I want to use this and that sort of, and the authorization server says, no way, you have to use this. Or in the case that it doesn't understand, it may also sort of remove, it may add stuff, replace or add. And this, of course, the authorization server that decides. The client just has to use whatever information that the server provides it with. The client, according to the OpenID Connect specification, cannot modify your registration. You do a registration, and that's it. You cannot modify it, you cannot delete it. If you want to change anything, you have to do a new registration from the start. Which, of course, creates a problem for the server because it doesn't know when it can delete a client registration. This is different from our proposal when it comes to OAuth, where you can actually sort of modify the registration. Yes?
We didn't say that you couldn't. We just didn't say how you could. The idea was that other protocols will come along and say the IETF version of client maintenance will.
Yeah, you do.
You know, I've been good so far. The idea is that other protocols, like the CRUD interface for in the IETF version of dynamic client registration, which is in a separate draft currently, but if we allowed, because we didn't know what the best way to do those maintenance operations were, we didn't specify a way to do it in the Connect draft. We only said how to register it.
Right.
You could have a private API for managing it. You could use a later developed method. So it's open for future expansion. It's not that you can't modify it.
True. I think it's worth noting at this point that within the OpenID Connect working group, we had to take a decision a while ago because we have dependencies on a couple of other standards within the IETF, and they never got finished. So at one point in time, sort of, the decision was just that we publish now, and we reference the IDs, IETF IDs as they are right now, and then we hope that they don't change. And that goes sort of along the same line as you were talking about. So we had to get something out. Okay, so the ID token then. So we have to go into the JOT land here. JOT is what's called the JSON Web Token. It's a way of packaging information. And, well, the pronunciation is JOT. I don't know why. It's Welsh. Okay, good. So if you have a yacht, then you can sign it, and if you want to do that, you have to sort of use the AWS standard. And if you want to encrypt it, you have to use the AWE. And basically, it sort of defines different parts. So you have a header which describes then sort of what kind of algorithms they have been using. For instance, if you do talk about signing, and then you have what you have been signing, and then the third component is sort of the signature. one of the benefits from doing this way, if you compare it to XML security, is that there is no normalization or anything like that going on. You get the exact message that was signed. So you don't have to care about sort of anything like normalization. It's base64 encoded, exactly. So it's transport safe. You can transport it anywhere. And again, sort of if you go back to XML security, it always breaks when it comes to normalization. But this is supposed to break.
It provides opportunities for wrapping it.
Right, exactly. Accompanying this is then two other standards. One is then how you represent cryptographic keys. And you saw reference to that before. The provider is sending you a link to where it has its keys, and those keys are then represented as a EWK S actually structure. And then you have sort of registered algorithms and identifiers to be used in this other context in the JWA specification. I'm not going to go any deeper than this. This is a talk by itself. So the ID token then is about the authentication event. What happened? When did it happen? Who did it? And so forth. And who was authenticated? And it's represented as a JOT. These are the required parameters in the ID token. It's the issuer, again, it's the same issuer as you saw in the provider discovery sort of response. The subject then here is the sort of identifier of the subject, which then could be either sort of a pairwise type of subject or a public type of subject. Intended audience, expiration time, issued at, and the authentication time. And these three should be different, of course, I guess. Otherwise, you will have a problem if it expires when you get it. And nonce is sort of the same as state. It's a way of binding when you did the authentication request to the ID token. So it's you have a sort of connection between the session you had when you did the authentication request and the ID token. Optional then is the authentication context class reference, which is a specification on what type of authentication that was done. AMR, which we talked about previously, is exactly sort of which methods were used. And this can, of course, be a list. Authorized party, that's the server that got this ID token. It may not be the intended audience, but that's the one that posts the authentication request, the authorization request.
It's the party that's allowed to present the token, which in many cases is the one that requested it, but so for the spec, the NAPS native application spec where you're going through a token agent, the authorized party is the client to the token agent, which is going to be presenting the token. So it's
right,
part of on behalf of type semantics.
Yeah, but I sort of disagree with you, because if you actually read sort of, I mean, you have written it, I guess. So you should have read it, but if you read the document, it says that it's supposed to be the same as the client ID of the requesting.
Yes.
The party that did authentication request.
Right, but it's transitive through the proxy. But we can discuss that.
We can discuss it.
It's an advanced feature. It will be used in NAPS. And Google uses it for the Play Store.
Because one of the things that isn't specified is that if the intended audience is different from the authorized party. That is, the one that is presenting the ID token and the one that is supposed to have it, sort of. If those are different, how did the authorization server know which the audience is supposed to be? And that's not specified, how that happens. Yeah, it's another document, but it's not part of the specification. It's not approved yet. Have anyone been at the baseball game before it started and seen this crew going out there? It's quite spectacular, I think. It was sort of a choreographed dance, sort of. They're going very, very specific. I just go there before just to see this. So the game is of course okay, but this is really interesting. Anyway, so this was sort of the basic, the OAuth2 Authorization Request. It's been changed now, sort of. It's been added to, you could say. So a couple of things has been added. One is the response mode. And that goes back to the response types. So if you had code, you would get back a get with query parameters. If you have a token implicit flow, you would get back something with a fragment instead of a query parameters. But that may not be sufficient for all cases. So one of the added response modes is post, which is the same as you use for SAML, for instance. It's quite normal that you get a response which is sort of a form that automatically is published and then ends up at some other endpoint. This has been reused here. So you can actually have something called form post. But you could sort of imagine even more mechanisms for doing this. Of course, you're not supposed to specify this if it's obvious from the response type you have chosen. Nonce, as I said previously, is a way of associating the client session with the ID token. Oh yeah, and then there are a couple of other things. You can do, you can sign and encrypt the request. There are some things connected with end user interactions, and there are some things connected with the response. And I go through these. If you want, I mean, normally you send this request and it's not signed, it's not encrypted or anything. You just trust that the transport, which is supposed to be HTTPS, protects this. So no one can sort of do anything with it on the way over. But if you want to be certain that actually what you sent arrived, you may want to do something like this. You may want to sign or encrypt it. And the way to do that is to use the request parameter. So you take the request as such. You represent it as a yacht, and you sign it, and you push it into the request parameter, and then you can send it over. It means that you may have an authentication request that contains a lot of parameters, and then a request parameter, which again sort of specifies the same parameters as you had. And then, if someone has tampered with it, may be different. They're specified in the specification how to deal with that. But this is one way of protecting sort of the request. It's self-contained. You can do this in two ways, either by value, as you see there, and putting it in the request, or you can just sort of put it somewhere where it can be found by the provider, and then you provide a URL so it can go fetch it. I don't know how I am on time. Okay, good. End user interaction. What's the end user supposed to do when it does the authentication? How are you supposed to display sort of the authentication page to the user? Are you supposed to prompt the user or not at all? The time since the last authentication, you can also specify. So you can say, if it was longer ago than 10 seconds, I want the user to re-authenticate. Locales, the preferred language for the user. This, of course, is interesting if you want to present the page or login page in Swedish, for instance. Then you should specify it here. ID token hint is sort of a previous authentication. This is what we used last time, and it worked sort of. So you can get some information about, for instance, which subject wants to authenticate. So you can actually pre-fill in that and just do the authentication. John wants to add something.
So that's particularly useful where some IDPs may allow the user to be logged in simultaneously with multiple personas. So you may have a Google Apps enterprise account and a personal account that you're simultaneously signed into at Google, and I personally do this all the time. So if you go back to a website, the website can use your previous session to essentially give that as a hint to Google so that Google issues an ID token for your personal or for your enterprise identity without having to necessarily reprompt the user which identity do you want to use.
Which is very useful when you have different authentication methods, for instance, for these two identities. So one may sort of demand that you have lower 3 or something like that, but another one might be okay with the LOA1 or something like that. So, and then lastly, you can say what kind of authentication context do I want to be used when you do the authentication. So you can actually influence quite a lot sort of what happens with the authentication and what happens. Response details. This is, you can specify when you do the request, what do I want to get back in the ID token. I can place more information than the ones I was showing you before. I can actually take user information like name or something like that and place it in the ID token. So I get all except from the authentication information, I also get the user information in the ID token. So I get all of it bundled into one response. And the claim specification, I can say null means I want to get the value. Essential means I really want to get the value. But again, sort of even if the client says essential, it's still the authorization server, the OP, that decides what it wants to do. And then you can specify that, okay, I want to use a specific authentication methods, and this is the specific authentication method I want to be used. And there I specify a value, or I can use values, which is sort of, I may want to use one of these. Nice colors. User info, this is a standard set of claims. And me, coming from educational backgrounds of working with universities, this is almost unusable. Because, as was talked about in the last session, except from the authentication, which is very interesting, and sort of you really want to do that, what you want to get back is information that can be used for authorization. And this is not that type of information. I mean, give a name. How would you use that for authorization? I don't know. Everyone that's named John gets to do this or something like that. But you can specify, there is nothing in the standard that says that you have to be limited to this. You can do it in several different ways. Either you can just sort of return more claims from the user info endpoint. Or when you can use scope, you can say sort of, I have the scope which is edu person or something like that. And then I expect to get back claims which are from that set of attributes. Or I can specify another user info endpoint, which is a SCIM user info endpoint, where I get back sort of information in the SCIM format. So there are several ways to handle this. So just because this is not very useful in our context, we are not sort of, OpenID Connect can still be used because you can do extensions to it. Also, my wife is a professor in psychology and works with gender. And I would be very interested to see sort of the allowed values for gender here. It's free form. Exactly. There is another interesting thing with OpenID Connect, and that is there are different claims types. Normal is that you get the attribute and value when you ask for it from the user info endpoint. If you use aggregated, it means that the OP it has gotten more information about this user from somewhere else. And it's then marked as coming from another OP, from another place, signed by that other party. So you can see sort of which information came from the OP you're talking to and which information come from somewhere else. But then you get everything sort of when you ask for the information. The third thing, the distributed, is that you don't get the information, you get the pointer. Over there are more information, and by the way, this is a one-time token or something like that, one-time password you can use to get at the information. In which case, the OP never sees that information. The client gets it directly afterwards. This is very useful. So in summary, and I think I'm good on time, 9 minutes. OAuth is about authorization, and OpenID Connect then adds information about authentication and about the subject. And it does it in a very comprehensive way, as I see it. That's a quick questions. And you post them to John. Sorry. Right. Yeah. Right. So the first was a comment, and that was about the set of attributes not being unusable. And I agree. Actually, I agree. I mean, for instance, if you're a wiki or something like that, and you use or another service, you want to personalize. You want to say, "Welcome, Pam. Good to see you again." Or something like
so the origin of that particular set was that the large social networks sat down and said, what are the attributes that 90% of the time somebody will need to do a registration? So those are almost, with some formatting differences, those are almost exactly the same attributes that Facebook would provide to a relying party as part of their registration interface. And Google and Microsoft and various other people said, yes, those are the typical ones that a relying party is going to require. There was somebody who's sitting over at the desk over there who was quite insistent that it should be based on SCIM. The compromise essentially was that if this is a simple set for registration, it can be extended with other attributes using different eduperson or SCIM, et cetera, or you can have multiple endpoints that, SCIM is more robust than just a read-only interface. You may want to allow read and write operations. So sometimes separating those things out into a separate API makes more sense than trying to overload the simple thing.
Another thing that's been discussed a lot within the SAML federations in Europe is that when it comes to attributes, you usually want to know where it came from and what's the level of authentication, level of authorization. So how good is this? It is self-provided or is someone else standing behind
the other thing that we didn't, you alluded to but didn't get into is that the values of all the attributes, when you extend them, can be complex attributes. So essentially every attribute can be a JSON object, which essentially contains metadata about the attribute, and in the request you can actually have structured requests saying I want age if age is over X, etc. So one of the differences in the request response between SAML and OpenID Connect is that we actually have a grammar for extending complex requests and complex responses, whereas SAML, you kind of have to base64 encode something into a value, and maybe it will work and maybe it won't if you're lucky. So that was something that a lot of people have been wanting in SAML but never really got standardized. So that is one of the advanced features of Connect, which we don't talk much about because most of the social web things don't want. But for structured attributes that are actually signed assertions themselves, which is the aggregated attributes and distributed attributes, there's a lot of things that you can do to extend that user info endpoint. As far as the auth and context class refs, there is a wonderful IANA registry where we, for both SAML and OpenID Connect, where we are collecting pointers to people's definitions of what these auth and context class references are, and hopefully through the registry will reduce the proliferation, but people are always going to want to have their own custom thing, but hopefully we can get down and use the ISO 29115 references and other common ones. So there is a registry, and the registrar will be happy to see your requests. I believe Sweden is, I did all the school districts in Sweden. They have registrations, but the U.S. government hasn't gotten around to it. So Sweden is far ahead on registering their
It's a small country,
schemes.
it's easy to do things. Just another comment to the attribute thing is that one problem that we have seen, again, in the federations in Europe is that a service wants a name, but the IDPs, in some cases, they have sort of common name. In some cases, they have a given name. In some cases, they have surname, and none of the others. So do you really want to ask for all possible attributes? I know that one service actually they asked for 20 attributes just to be certain to get one of them. So one of the benefits then, which we're using in OpenID Connect is the scope. So you can actually say sort of within scope that I want this type of information. Like you could have a scope saying name, for instance, and you will get the name whichever one was populated.
Does OpenID Connect support multiple domains and trust relations between them? For example, IDP trusts Y IDP, but Y doesn't trust
So
or the level of trust those domains.
So can relying parties manage their own trust relationships and trust one IDP and not another. And yes, that's completely up to the relying parties to decide. Trust relationships between IDPs. There is no requirement for a trust relationship between IDPs. I don't understand the question.
So if there are multiple levels of authentication, let's say
Oh, how?
trust fallen for PKI and trust fallen for biometrics.
Well, it's normally the relying parties that have to trust the IDPs, while there are reverse things with releasing attribute bundles and other things. Essentially, it's up to third parties, federation operators, or other certification bodies to have things like trust frameworks that will accredit identity providers as following particular standards, so that when you say you're doing ISO 29115 level 3, your ISO 29115 level 3 is the same as somebody else's. But that's not directly in the protocol that relies on, you know, external trust frameworks, the same as it does in SAML. You know, it's
take a quick, like, 10-second break, but I want to say thank you to Roland. That was fantastic. Appreciate it.